I'm going to be doing problem 39 from chapter 8. So there's a 4 kilogram particle that moves along the x-axis. Kilogram particle. Okay, its position varies with time according to x equals t plus 2t cubed, where x is in meters and t is in seconds. Find the kinetic energy at time t, the acceleration of the particle and the force acting on it at time t, the power being delivered to the particle at time t, and the work done on the particle in the interval t equals 0 to t equals 2 seconds. So the first part of this is finding the kinetic energy at any time t. So we know that the equation for kinetic energy is 1/2 mv squared, and we have the mass, but the only thing we have to find here is the velocity. But they give us the position, how the position is at each moment in time, and so we know that if we take the derivative of this dx dt, that is equal to velocity. That is 1 plus 6t squared meters per second. Alright, so we can take this velocity and put it in here to find our kinetic energy. So kinetic energy equals 1/2 4 kilograms times v squared. So 1 plus 6t squared squared, and that is meters per second. So we can just keep that over there. Calculate that, and it'll be 72t to the 4th power plus 24t squared plus 2 joules, since kinetic energy is joules. Okay, so B, the acceleration of the particle and the force acting on it at time t. Okay, so we had the position here, we had the velocity here. So to find the acceleration, we can just take the derivative of velocity. So since velocity was this, the derivative dv dt is acceleration, which is 12t meters per second squared. Okay, and the force acting on it at time t. So we have the acceleration in terms of t, and force is equal to mass times acceleration. The mass is 4 kilograms times 12t meters per second squared, and then the force is equal to 48t newtons. So that will allow us to find the force at any time t. Okay, part C is the power being delivered to the particle at time t. So the power is equal to the force vector dot the velocity vector, and so we know that our force vector from part B is 48t newtons dot the velocity vector, which from before is 1 plus 6t squared meters per second. Multiply that, and 48t plus 288t cubed watts. Okay, part D is the work done on the particle in the interval t equals 0 seconds, t equals 2 seconds. So work is the integral of power over time, and so we're integrating from 0 to 2 seconds. And then we have our equation for power from before. So 48t plus 288t cubed dt. And here that's watts. The unit for that is watts. And then anti-differentiate 24t squared, 72t to the 4th, 2 equal to 1,248 joules, which is approximately 1,250 joules, which is how it is rounded in the book. So that's the answer.